Hey there, welcome to the course. I have a ton to say, but first, I just want to add, please do not skip this section. I know it's tempting to go ahead to installation or dive into the code, but this course has multiple starting points, and this section will help you understand where you should start based off of your computer you're using and also your experience level. I know this intro stuff is not the most enthralling content ever, so I have thrown in some adorable photos of my cats. Here's one. Just look at those eyes, right? So I'll introduce myself very quickly. My name's Colt. I have some emojis here. That's me as a developer, me as a teacher. I have cats. I prefer dogs. Sorry, cats. Prefer dogs. I live in San Francisco, and music. Yeah, how unique. I like music. People in all sorts of different languages for 5+ years in person at bootcamp programs in the Bay Area, and then online on platforms like Udemy. Okay, enough about me. Let's talk about you. Quite a topic, and I decided to make the course not only as comprehensive as possible, but I wanted to make it open to many different levels possible. Whether you're a complete programming newbie, you've never written a line of code in your life, or in other languages and you just want some help translating over to Python, or you've experienced already, but you feel like it's not complete, or you want more practice with exercises, this course can help. Of course, the experience you have will be significantly different depending on your skill level. I do that in the exercises video later in this intro section. And as a side note, it's particularly focused around building websites or data science or automation learning or game development or anything like that. It's a broad course, but the goal is to take course and go on to learn any of those topics that are built on top of Python. The last thing we'll talk about in this video is a rough walkthrough of the curriculum. We start off with the very basics of Python, getting running with the command and your going. Then we move on to the basics of the Python language. We start with really simple stuff like variables, data types, Boolean and conditional logic, build a couple versions of rock, paper, scissors. And we move things like loops and building some simple games with loops. Then we talk about data structures. Dictionaries. We have a ton of exercises for each. Tuples and sets. Then we get to functions, which is the first notional video. But if we look at the function section, it's full of exercises. It's hard to tell on the curriculum, but each one of these little bracket symbols means it indicates an exercise. So you can see there's a ton of them in this section. These are videos. And then following it, there's this entire section of exercises. So there's a ton of exercises as we go. Functions part 2. We move on to, there's a whole other problem set then just some trickier topics like lambdas and built-in functions. Bugging, how to run exceptions. We talk about tools, and this is a fun section. We with external libraries tools that we have written to help us do some cool things. Start working with HTTP requests, connecting with APIs. I did make this section optional. If you know the world, Python talks to an API or something, then you can skip this. It doesn't ring up until the very end of the course. Then we talk about two topics that are kind of notorious in Python, generators and decorators. Shy away from topics like this. I've done my best to make it as accessible as possible, as you can see. Then we talk about OOP, object-oriented programming. OOP start here, up, down here. There's a ton of content between these sections on object-oriented programming. We build a little application. Continuing down, we talk about testing and driven development. There's a lot of ways of, if you're familiar with testing, a lot of ways of testing in Python. We cover them. Then we talk about file I/O. So this is a fun topic. How do we save? How do we sort of CSV file containing crime? How would you read that in to analyze it using Python? And then finally, my personal scraping. That doesn't have a publicly available API, pull across hundreds of thousands, and we extract data from those websites. So we built our own provider using Python that and extracts book data from an e-commerce website, 100 links, that sort of thing. Small and a ton of material, as you can see. Each one of the sections, almost all of them have 5+ exercises. Some of them have 20 exercises. It's a lot. And frankly, those exercises to write all the code goes into all testing logic than it was for me to record 20 something hours, 25 hours, something like that. So hopefully you enjoy having all those exercises at your disposal. All right, so that's the curriculum. In the a really important question, which is why does this course cover Python 3? How is it next? All right, welcome back. Let's quickly chat about Python 2 versus Python 3. So if you're probably used to your software updating and changing all the time. Whether it's your phone's operating system, your game, these things change no different. They're always enhanced, they're always changed. New features are in the process of growing. So back in 2008, the creator of Python, we do really important architectural decisions early on in Python. Change them. So he decided to overall release Python 3. So this year is 2008, and at the time for Python 3 to be the present of the language, people were supposed to iterate pretty quickly and stick with it. But as you can probably tell, just by the fact that I have to make this video, more. And the reason all Python is not backwards compatible. Usually when you have a programming language made in a way that can still run. So description, there won't be any problems. It won't be using the new features. It's nice, but it will still work. Python 3, the opposite was true. The existing companies that were built on Python 2, their code they had done up until that point would not work in Python 3. And because of that, still to this day, Python is still commonly used. But that wasn't always the case, because it's taken a while for companies and libraries to fully support Python 3, because it had to be a decision. Oftentimes, they update to it without thinking, but going from Python 2 to 3 is a very deliberate choice. You team at a company that had to decide to make over 10 years later, and it's still not fully solved. So this is a little diagram. Back before Python 3 came out, it's one guy developers building 2.x, and they say hi to each other, they send hearts back and forth. It's real happy. But then Python 3 came, which was an attempt to make Python great again. And there was very mixed reactions, as signified by all of these emoji here. It was very what ended up being torn apart. And if you're someone who's trying to Python for a while, it's been a good start. There are thousands and thousands of blog post videos where difference and talk about why you have to learn Python 3 or how to decide if you're new. It goes on. There really was a lot of ambiguity around it. Python 2 was definitely, but things have changed. It's just been really slowly, very incrementally. But also, Python 3 is out of the way. The situation has improved. So what makes that? First of all, it's just easier to learn in Python 2 for some reason. You can differently. Most of the main criticisms, the things people didn't like, just don't matter anymore. It used to be that all the popular packages that people would use, the utilities that were written for Python, only in Python 2. So if you get to Python 3, you was Frontierland, where you couldn't rely on common packages that you were used to. But that's no longer the case at all. There's a website here, I'll include the link, called Python 3 Readiness. And it's 160 most popular Python packages that are used. All the important things that you would ever need to do, well, not ever, but most of the things you'd ever need to do, they are all supporting Python 3 now. Out of the top 360, that aren't. And you can see them here highlighted in white. But everything else is supporting Python 3. This just a couple years ago, it was a much different picture. So many of the older courses still include, because at the time, that's what everyone was doing. But like a situation has changed. All the popular packages you'd ever need support Python 3. So the most compelling reason, honestly, is that Python 3 is the future. There's also the fact that Python 2 is going to be retired officially. So Python 2.7 is still being maintained now. But in 2020, there's not an official date. There's going to be a time where it's not maintained. So there's not going to be these two versions going forever. Python 3 is designed that lives on. So everybody who's learning Python 2 right now is going to have to move on 3. If you're curious what this is, it might be learn Python site. This is between 2.7.x and 3.x. So one just really quick example I'll show you. One of the first things we'll learn in this course is called the print function. And in Python 3, it looks like this: print, and then parentheses. We pass print. In Python 2, print was a statement rather than a function. So you didn't add parentheses. You could do it like this: print space hello. I3 add the parens. So it's a minor difference, but you can see if you wrote code in Boolean and you didn't have those parens and you tried to run it in Python 3, it wouldn't work. That's no longer valid code. So if you are a complete beginner, are deciding is Python 3 at this point, all of the blog posts, criticisms, find out that and they're out of date because the situation has changed. And just remember that Python 3, I sound like I'm trying to sell it to you or something, but it just is. That's the developers of Python have made it clear that Python 3 is where things are going. Why not in Python 3? And finally, one more picture of my cat. That was a long video. Look at that. All right, welcome back. So I'd like to quickly talk about the exercises in this course. As if you watched the promo video, you saw there are a ton of exercises. That's what makes this course unique. It's what I'm most excited about. But I need to make a quick video to explain a couple of things about them. Exercises should keep you busy, but they aren't distributed evenly across the course. I wish I could have tons of really exciting exercises early on, but the way that it works, we just know enough. So early on, in the intro section right now, there's no exercises. Let me talk on numbers, operators, a few more exercises in there. Variables and strings, we start to open up a bit. And then afterwards, that's where the bulk of the exercises are. Because unfortunately, the beginning of a course is really important. But the selling point are how many exercises there are, and there just aren't as many at the beginning. In order for the platform to work, you have to be able to write certain types of code. You have to know how to function, and it takes a couple of sections for us to get up to speed on all those topics. So please have faith if you're getting discouraged about the lack of opportunities to type code in the browser. I still try my best to make it interactive and somewhat exciting, but just keep in mind, after this, you make it to the magical exercise wonderland. There's rainbows and these emojis and these people doing this thing with their hands. It's way better. So it just takes a little bit, but a ton of exercises. All right, so one thing I'd like to talk about is how these exercises are structured. Tons of them, you'll see this a lot. You never have to write all your code in the shoulder. If you're more comfortable, you skip all these exercises and just run code on your own computer and leave the browser. But if you do want to use the tests that I've written, all of these exercises, prompt, this is one of the simplest ones. It has to do with functions when we talk function syntax, but write a function called speak that returns oink. Yep, that's it. Very interesting. So you write your code in, and let's say I don't know what to do. So I get it wrong. So I say, I don't know. This is not a good idea at all. Let's just say that's what I did. That's not real Python code. But I would click check solution, and it's going to tell me. And what I want to show you is that some of the error messages that you'll see early limiting or confusing. For example, this one, I don't know what it tells me that it's, but all of this extra stuff is there as part of the message. All that it is that this is not real Python. It results in all this craziness. So if there's ever a point where these messages aren't helpful enough, I've done my best to add in some helpers to try and get early on. There are common mistakes, so I try and add scenarios. So I write code that checks, did they do this mistake, give them this nice message. But it's hard for me to anticipate all of those, especially when the exercises get harder. So just keep in mind that sometimes you might see some crazy error like this. And if you ever just need to see the solution, whether you up or you just want to check on something, or it's always immediately following the exercise. So you didn't have a way for you to just download a solution file right here. Manually, I had to create a solution file. So this is the super quick return exercise. Immediately after is solution. So you can click on it there, or just click and and then go back, paste it in, using that code. Well done. Got it. Okay, so I just want to show you how I have this set up. Udemy was never expecting there to be so many exercises in a single course, so they didn't really with a solution code for tons of exercise. So I came up with my own system. It's on also change over time, but for now you just click continue. You see the solution. You continue. There's another exercise. In this case, after that would be the same, so on. Hit continue if you want to see the solution. Okay, and then also remember. All right, I'll be quiet now. Let's get on with it. Hey, welcome back. This is the last video in this intro section. After this, we dive into the meat of the course. But this is still a really important topic. It's all about, let's just get on with it. Teaching online, but going from that my pace, how things are going for students. For time to look at people's faces and see if they're bored or if they're asleep or and they're lost. And you also it's a dialogue. Online, it's recording. It's like a crazy person, with mattresses on the walls to keep them. So it's different. From angry right down to angry again. I could have one exact video on, the return statement in Python. For some people, it'd be going too fast. Others will say, slow way down, not quite as frantic. Someone might be little, and maybe one person. That's what I needed. Other people are going to say, this is way too slow for me. I already know this, hurry up. I'm super, super bored. 1 star, you suck, I hate you, this is awful. It runs the gamut. So from my perspective, I have to figure out what do I teach to and how do I make this work? Without sounding too preachy, I approach a ton of content and I make a lot of it optional. It's really all I can do to accommodate everyone. It's okay to skip things. And at the same time, if you're somebody who you need to take your time, this is new and intimidating to you, add in a ton of exercises, additional reinforcing material that you can rely on. 2 very different levels, different paces, and different learning styles could have a different set of videos. For example, here's some of the content from the function section later on, or 2 sections actually on functions. Imagine that you're going through, watch the first couple videos, you do the first exercise, and you feel good about it. Code along. This is, I always make it clear in my videos. I'll say, this is optional, skippable. In this video, I'm going to do more of what we did in the last video. So you could try the next exercise. And you might skip this one. Then you watch more videos. And then there's a whole problem set. So some tackle every problem in here. Usually when I have problem sets, I arrange them from easiest to hardest. So if you're feeling good, you might skip the first couple. You might try the first one, realize too easy, skip one, try another chunk, then try the one at the very end to test yourself. There's just flexibility built in. So I don't want to sound, like I'm figured out how to teach online better than anyone else. I'm just trying to tell you how I approach it personally. I know it's impossible to style. People are always going to find things that are too fast or too slow for them. But I've built it that way that you can. Part of that is how I see this average. There's goals and objectives section at the beginning. Talking maybe 30 seconds about where we're going to contact. We're going to learn functions. This is what then there's the meat of the video, which is 80% most of the new material, and then a recap or summary at the end. So I'm telling you, for some students, those are really important sections, the recap, the goals and objectives, to set the material in your mind, make a mental map. But for others, it could just be monotonous and slow. That's it, skip it. In fact, what will probably happen is people will add bookmarks on the video platform where people will bookmark the most important parts of a video, and often in my videos people bookmark after the goals and objectives or at the recap so that you can skip to them or skip away from them if that's your goal. And lastly, if you feel the course is too slow, I highly recommend the video playback speed. Use this as an option. Personally, when I watch it on YouTube or some, I'm going to learn to make my own animations because I don't have, but if I did, they would be. So I'm trying to learn that, but I like to turn up the video speed. It's bothersome to listen to somebody talk slowly. And criticism about myself, its opinion is that it's best
to allow people to speed me up if they want to,
or slow me down,
rather than ahead of very fast or very slow. So just keep that in mind. It's up to you. I know goes without saying, your life, you can do what you want. I recommend that you speed up the videos if you could go for that to frustrate you. And same thing, if you also check understanding as you go, use the exercises that I've built in to see if you need to watch every video in a section. If you feel good about functions or lists, then don't do every exercise in a section. Anyway, I think I should stop talking now. There's a lot in this course, so I just want to make it clear that I'm trying my best to make this as friendly as possible to people from all different backgrounds learning. If you get this, you can keep it that way, and if you hate it, you can kind of choose your own adventure. And lastly, look at that little kitty in a sink. Sinks aren't for cats. Alrighty, let's get started. I'll see you in the next video. All right, so we've been working with numbers. It's kind of boring, I know. We've been working with 1 and 99 and 73, all very great numbers, especially 73. It's a great number, but very limited. So we might use numbers to do things like, store the price of something. That's a really common use case. Or the things that Python says, okay, sure, but there are other things. And but I want to be clear, this is not comprehensive. Probably you more go. So I just want to make sure you don't. For example, floats work not listed here. I'm going to just walk through some of these. Don't feel to hang on to every word because dictionaries are going to have some of them. All right, so let's kick things off. Booleans. It's kind of a weird word than before, but they are just or no values, on or off. Bits of light that are flashing on or off. So you could use a number. You could say true, it means it's off, or that it's true, false. There's no reason to understand. Just remember, and space has to be allocated in memory for S value that it's only going to make a little. And that's not the only reason that it's useful. We're in logic later on. So here I am in my terminal in Python 3. So I can just type the words. Have a capital T, by the way, or a capital F for false. That's how knows. I could just type it like I could type 989 and get the return back to a variable as well. So I could do something like is active and set it to true. And I look at is active and I get true. Or I could have a variable called game over. Game over start out as false. So this is actually a really standard way of writing or any game where the game keeps going until you lose or until we could have game over set to be false, and then at the end of the game to be true, and the game is over. Now, obviously, there's a lot of logic that goes in between two things. I need to point out, though, is that we can't do this lower because it's no longer Boolean. So Python recognizes it based off of that F thing, a special idea reserved for false. And if I do is not defined, I don't know what you're talking about. So uppercase, really important. So I know it seems silly at this point, Boolean values, they are very useful, and it's not just a shorter way or a more compact way in memory to store yes or no values. There's actually a lot of operations that work with Booleans that we'll see later on. Okay, so next, I'm going to devote this section to, but the idea is that a lot of times, basically any unit, so they're in between quotes, double, which we'll talk about later, but they're in quote, name, cult, or something, or it could be just the number side of quotes. That makes it a string, not a number. So here's an example. Just call string. I could set it equal to the number 8. And if I look at some string, remember that we have this thing type. Let's do something. Hey, it's a string, str. Versus doing type of 8 is an int. So I can also do some string equals, and instead of quotes, I'll do hello, I am a string. And I'll put an exclamation point just to show you it's not just numbers and letters, it's any valid Unicode character. Now I string, and we get that back. Okay, so strings, I'm not going to waste too much time in this video because we will spend a lot of time with them in this section. They're very useful. So this is how you would probably store things like of an item on your store. Something like jar of crunchy peanut butter. Even though smooth and creamy is arguably better, we could store with a string. All right. So the last we're going to go through, I said they each get their own section. They're more sort of like they have level in that they actually store data inside of them. They're what's known as structures. So the first called an ordered sequence of values. So here's an example. 1, 2, and 3 are strings A, B, and C. Examples, but the idea, well, they to be testable, but the idea is that you can store it in a list and there's an order. So maybe it's a shop. I'm sold out of my peanut butter. This homemade peanut butter with those peanuts I don't grow. I've listened to people who are interested in it, right? I don't just want to have a group together. So it's first in the list. Okay. Dictionary different. They work, there's no order first, and that corresponding value stored together. So people have alt, and then last name is set to zero. So then have two, we can put them together by using a dictionary. It's what it's here signify a list. So if that makes it, I sweat working with these. They're really common, but again, more integers, floats, strings, and then we have data structure. They store other bits of data. Okay, for now, body type, but really we're going to focus on strings for the next couple videos. All right, one last thing before strings. I want to talk about dynamic typing. So Python is a language that is really, really flexible about how we define our variables, and it gives us the ability to reassign our variables, not just from 99 down to 98, but we go from 99 to the string none or 0 in quotes, the word 0. So basically, it allows us to have variables change types, not just values from to a number or a string to a string, but the actual type. So for example, we could have awesomeness set to, what is this again? Boolean, capital T, true. And I could print awesomeness and it's the Boolean true. But then I could change it. The same variable awesomeness, it's not a different variable, and set it to a string, a dog. Or I could set it to something called none, which we haven't talked about yet, but none is another value. Notice it has a capital N, so it's not a string. It's say that Python represents the concept of nothing. So it's different than 0. It literally means nothing. We'll talk more about it when we get to that point. Then we have awesomeness equals 22 divided by 7, and the result of that is a float. So this is just something that it's good to be aware of. But this is also something that is somewhat unique to Python. So there are other languages that support dynamic typing as well, but there are lots of languages that don't. So for example, languages like C++ are what's known as statically typed, which means when you define a variable as a Boolean, it has to stay as a Boolean. And if you want to change it, well, you actually need to make a brand new variable, and you can't really dynamically change things at all. So as an example of what that could look like, take a look at this code. We have a variable called not awesomeness. We're setting equal to the number 5. But we actually have to say ahead of time, this is an integer. It's always an integer. And in C++, also notice the semicolons, it's going to always expect it to be an integer. So we could change it. We could change it to 7 or 20 or 1 million. But if we tried to change it to a string, like cool, it would throw an error and break our code. So that's it for this video. I just wanted you to be aware of the fact that Python is dynamically typed. You can change data types of variables at any point, unlike other languages like C++, where you have to define a data type from the beginning, and that variable always stays